This is our chemistry project by Emily Altamirano, Allison McClanahan, and Kayla Papillon. As we began to narrow down our options for tin replacement, we went ahead and chose these three characteristics: electronegativity that is relatively close to 2, metalloid, and the state at room temperature, which needed to be a solid. We were then left with these four elements in the middle: tellurium, silicon, polonium, and germanium. We then completed and gathered research over the color, luster, density, hardness, melting point, heat and electrical conduction, and whether the element was malleable over these 5 elements. Our first to be eliminated was silicon because tin had a hardness of 1.5 while silicon had the greatest difference at 6.5. The melting point of tin is around 231 degrees while silicon has the greatest difference around 1414 degrees. Another difference is tin conducts electricity and heat well while silicon does not. Overall, silicon had the greatest amounts of differences compared to tin. Our second to last elimination between the elements was polonium. The main factor that changed our minds to eliminate polonium was because of the high toxicity towards humans. To add on to this, polonium was not malleable, which plays a big role on plating just as tin does. Other than these differences, polonium was a considerable option at the start because of the luster, density, placement on periodic table, heat conduction, and electrical conduction originally made it look like a good option. Tellurium was the last element that we decided to eliminate because although it shared a lot of characteristics with tin, it's very rare and burns when reacting with air. Our group believed that germanium would be the best replacement because it was the closest metalloid to tin. They're both great conductors and they react about the same. They're also pretty close in abundance and share the same mining countries. Germanium wouldn't work as good as tin because it's not malleable, it has a much lower melting point, and it's much more expensive.